students, welcome back to my channel. In this we'll see what is exercise 7.3 chapter 7 permutations and combinations. So previous video we did exercise 7.2. Now we'll be doing 7.3. So here what's the first question? We'll see how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated. So here no digit is repeated over here. You have seen this last exercise, how did we do such type of problem, or in the introduction part I also told you about what is permutations. You have what is the formula used for permutations, where you have to select some numbers from a given set of digits. In what way can we do? We use the formula NPR is equal to n factorial by n minus r factorial, where here our n is equal to total number of digits and here r is equal to number of selected digits, or which number we have to form. Okay, so that is 3-digit numbers. So here n is equal to how much? We'll see. Here we are having what are the different digits from 1 to 9. If no digit is repeated, we have to see. So digits, which 3-digit number which has digits 1 to 9. So what are those numbers? 1, 2, 3, so on up till 9. So we are total digits is equal to this. We can write it as n is equal to 9 over here. And what is r? R is the number of digits, 3-digit number we are going to form, so that is equal to 3. So here the formula we are using is 9p3 is equal to 9 factorial by 9 minus 3 factorial, which is equal to 9 factorial divided by 6 factorial, which can be written as 9 into 8 into 7 into 6 factorial divided by 6 factorial. So 6 factorial will get cancelled. So you're getting 9 into 8 into 7, which is equal to 72 into 7. So you're going to get it as 7 2s are 14, 7 7s are 49, plus 1, that is 50. So 504 3-digit numbers can be formed by using the form digits 1 to 9 if no digit is repeated. So now next we'll go into the next one. What's the second one? We'll see here now next. So now here in the second problem, what we have here is how many 4-digit numbers are there with no digit repeated. So here in this we have 4 digits. So how many 4-digit numbers can be formed? So you know how many these, what are the numbers which we use for forming a 4-digit number? You can use 0, 1, 2, 3, 4, so on up to 9. So you have to form a 4-digit numbers using these. So now if what is the method which we use is, now you have written, suppose here 1, 2, 3. If you put a 0 in the start, it will become a 3-digit number, not a 4-digit number, because it's starting with 0. So therefore whichever number starts with 0 is not, the start place should not be in the first place. It can come in the next place, because next 4-digit number can be formed in this way. 1 0 2 3, you can have 1000. So it's a 4-digit number. So here only in the first place you should not have 0. So 1 to 9 should be there in the units, the first place over here. So here now by the principle of multiplication, by multiplication principle we know how to do this, isn't it? We did some of the 7.2 exercises also by this method. So by multiplication principle, so now here in the first digit over here you can have from 1 to 9, you cannot use 0. So what is, so it can be done in how many ways? From 1 to 9 you can choose any one in these 4-digit places, isn't it? So from 1 to 9, so it can be done in 9 ways. Now second digit can be done in how many ways? Now one digit is used already. Suppose if we take out 1, now you can use this even 0 in the second digit place. So how many are available? 9. Now again in the third place, now 2 digits are already used, so you can use even this also. So now how many, which using even 0, it will be 8. Now for the fourth place, if you use even 3, how many digits are left over? It is 7. So therefore here you are having, this is 81 into 56. So this, if you do 4, 5, 3, 6 number of digits, 4 digit numbers are there with no digit repeated. This is the number of ways. Now using the permutations formula, how do we do this? We'll see. So now you're having here 4 digit place. So how to use the formula and do OR? This is OR method which we can use. So now here you're having this 3. We know that this 3 digit numbers can be done from any of this digit 1, 2, 3, 4. In how many ways? We have already seen that it is done in 504. And now when we are taking 0 also into consideration, 0 cannot be in the first place. If you are filling up this one, this first place can be filled out in any of these numbers, that is 1 to 9. So it is 9 into 504, which is equal to 4536 is the answer. So even using the other formula, that is NPR, using the principal permutations formula also, you can do this problem. By this method also getting the same answer. So now going into the next problem. Also next problem we'll see. Now what is the third problem? We'll see. The third problem is, how many 3 digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated. So here in the solution, you have to form a 3 digit number. Okay, and this 3 digit number, it should be an even number. The condition given is, it's a 3 digit number, it should be an even number. And what are the digits which are available for us to use? 1, 2, 3, 4, 6, 7. So all those numbers which end with 2, 4 and 6, then it is said to be an even number. So where this third digit, this can be done, this digit can be done in 3 ways. So total number of digits are how many? We are having 6. So now we are in this place, you have already used either 2, 4 or 6. So here in the first place, what can be used? It can be done in how many ways? 1, 2. You use 2, suppose you use 2. So you can use here, you use 2, 1, 2, 3, 4, 5, isn't it? So it is 5. Next can be done in 4 ways, because 1 is already filled, isn't it? So because 1 is filled, if suppose this is already used over here, so the other number of digits which are left is 4. So second digit can be filled in 4 ways. The third digit is, because it has to be done in by only 2, 4 and 6, so 3 it can be. 60 is the number of ways we can arrange this 3 digit even numbers can be made using the digits 1, 2, 3, 4, 6 and 7. Total number of 3 digits even numbers possible is 60. See over here, you have to understand, it's very simple. The first digit, because you know that the last digit has to be done by either 2, 4, 6, we are removing one of the digits from 1, 2, 3, 4, 5, 6. So when you remove one of the digits, you will be left with 5. So the first one will be filled in 5 ways. So the next one, because already one of the even number is gone and one of the number, suppose you are filling it with 1, what are the numbers left? Out of 6, 2 are removed. So 1 2 3 4, 4 ways it is done. And then the last one is 2 4 and 6, you can write that in 3 ways. You can either get 2 4 or 6, so it can be done in 3 ways. Okay, going into the next problem, 4 digit numbers that can be formed using the digits 1 2 3 4 and 5. No digit is repeated. How many of these will be even? So now here same, will be using the multiplication principle. So you are having the number of digits over here, or what? Number of digits is equal to 1 2 3 4 and 5. So here our total digits is equal to 5. So now here you have to form a 4 digit number, 1 2 3 4, right? So now this 4 digit number, by using multiplication principle, so here we have to find out 4 digit numbers if no digit is repeated. So by multiply, the first digit can be done from these 5 numbers. One of them can be filled in 5 ways. The second digit can be done, because one is filled means what is the number of digits left out? 4. So this can be done. Second place can be filled by any of these 4 numbers. Now the third digit can be filled, if even 2 is there, the third digit can be filled in any of the 3 numbers. Then the last digit which is there, it can be filled in 2 ways. So which is equal to 5 4s are 20, 23s are 60, 62s are 120. So now here next he is telling it, this is no digit repeated. Now second, you have only even numbers formed. What are the even numbers formed? So now we have 1 2 3 4. You have to form a 4 digit even number from the digits 1 2 3 4 and 5. So now here this units place should be an even number, and this can be done in how many ways? Because there are only 2 even digits, it can be done in 2. Now because here 1 is already filled, you remove one of them. So now this first digit can be filled in 1 2 3 4 ways, right? And the second one, suppose you remove this. Now next, the second one can be filled in 3 ways. Then again the third place can be filled in 2 ways. So therefore 4 into 3 into 12 twos are 24, 24 twos are 48 even numbers can be formed. So therefore 48 even numbers can be formed from the given digits. And these are 48 4 digit numbers I have to write here. These are 4 digit numbers, whichever we are writing over here. So now what is the fifth problem? We'll see what's the solution of this fifth problem. In this we have, from a committee of 8 persons, how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? So here you have from a, now total in the committee, how many are there? Committee of 8 persons. So 1 2 3 4 5 6 7 8. So in how many ways can we choose a chairman and a vice chairman? So we have to choose 2 positions over here. So over here, assuming one person cannot hold more than one position. So both of them cannot be the same person. Chairman and vice chairman should be different. So here it is, you can do by multiplication principle also you can do. So now we have total number of persons over here is equal to 8, and total positions is equal to, or selecting 2 persons out of 8 persons. So here, how do we do this? Now this is n, r is equal to 2 over here for us. So you can use npr, which is equal to 8p2, which is equal to 8 factorial, because you know npr is equal to n factorial by n minus r factorial. So 8 by 8 minus 8 factorial by 8 minus 2 factorial, which is equal to 8 factorial by 6 factorial, which is equal to 8 into 7 into 6 divided 6 factorial divided by 6 factorial. So 8 sevens are 56. So in this way you can select 56 ways we can choose a chairman and a vice chairman for those two positions. You can do even this problem by multiplication principle also. This can be done by multiplication principle. How do we do this? Because we are having two positions, this is 1 and this is 2. Out of how many you are having? 1, 2, 3, 4, 5, 6, 7, 8. So the first person can be selected in how many ways? Now along this you can take out one of the number. So suppose you are selecting a 1, this first person. So now remaining are how many for the second position? They are 7. So it is equal to 56. You can do by any of the methods. This is the one method, or this is one more method. So this is the way we do fifth one.